Okay, welcome to 2-8 Literal Equations and Dimensional Analysis. Wow, this sounds pretty intense, but really don't even worry about it. Actually, all we're doing is solving equations, but not just solving them for one variable. We are still solving for one variable, but now there are these other variables in the equation. So it's literally all the exact same steps you guys have already learned, but now we're just choosing a particular thing to solve for. Instead of, oh, we only have the x to solve for, so we'll get that. Now we're going to choose what should we solve for. Okay, and again, exact same steps. So don't be stressed. Let's try it out. Here's an example. So it says solve for z. Solve for z. So I want z, right, by itself. I've got all this stuff. U equals 3w plus z. Okay, but so my question to you is, what is happening to z, and how can I get rid of the things that are happening to z? That's going to be essentially your question every single time. So let's see. All right, well, we've got this 3w over here plus z. So remember, these are just numbers when you put in a number for w, when you put in a number for u, and a number for z. So they're just numbers. So we can treat them similarly. 3w. So what's happening? It's being added. So if it's being added, what inverse operation should I use? Well, I should use the additive inverse. What's the additive inverse of a positive thing? It's a negative thing. So I'm going to do that to both sides. Okay, and then here's where you guys might get worried. Well, what are you going to do with u and w? Well, you're just going to leave them because they're not like terms, so you're just going to leave them. So we've got u, and we've got a negative 3w. And look what happens here. These cancel, right? Of course, we chose that for a reason. Okay, and what's left on this side? Just z. And we're done. That one was pretty quick, right? Okay, how about this other one? How about this other one over here? Okay, az plus 7u equals 3az plus 7. Okay, now this is really looking crazy. Now, again, we're gonna try to solve our stuff, get z alone. But there, look, we've got two places where there's z. Okay, two places where there's z. So, let's take a look at this whole quantity and see, do we have any directly like terms? Okay, maybe like terms. And it turns out az. How many az's do I have? I have one az, right, over here. And then I'll leave my other stuff the same. I'm just kind of rewriting this for ourselves to look at it differently. U equals, and how many az's do I have over here? I've got 3 az's. Okay, so these are like terms, even though they're two variables multiplying times each other. They're still like terms, and I still have my 7 over here. So if they're like terms, I can combine like terms across the equal sign by doing what? Well, by applying the additive inverse. So I'm going to, the opposite of 1az, the additive inverse is a negative az on both sides. A negative az on both sides there. And this one's going to cancel. And how many az's do I have? I've got 3, and I've got a negative 1. So right, different sign, take the difference. And so that what's going to be left? I'm going to have a total of 2 still left over. 2 az's. All right. And then I've got plus 7. And this is still 7u over there. Okay, now what's happening to our z variable? Let's go back to just, now we've got our az's taken care of. And remember, we're still trying to get to z. So what's happening here? Well, we've got a couple things. We've got this 7 being added, and we've got a being multiplied, and we've got 2 being multiplied. So what comes first? Remember this guy, sad mep, right? When we're applying inverse operations, we're going the backwards direction, right? A backwards direction. So we got to apply our additive inverses before multiplicative inverses. So let's do that. That's a negative, I'll use the red here. That's a negative 7 to both sides here. Negative, that's like minus, or plus a negative 7 on both sides, because that's going to cancel this 7. Okay, and then we have 7u. It looks like, oh no, there we have 14u. No, these are not like terms. They are not like terms, so we can't add them. So just leave them. That's fine. We can leave them. Okay, and that equals 2 times a times z. Okay, so here's where you're going to freak out maybe and think, well, yeah, I know that when I have multiplication times a variable, I'm supposed to divide, right? Apply the multiplicative inverse, division, or multiply by the reciprocal, which is the same thing. But here I have two things. Well, check it out. Simply apply the multiplicative inverse, or divide, right? Both things, because they're both being multiplied. So divide both things. Right? Divide the 2, then divide the a. You can do it in 2 steps. You can do it in 1 step. Your choice. Because look what happens when we choose these inverses. When we choose these inverses, they cancel. And what's left? Z, only z. Only z here. And we've got all this stuff. But look, I can't even simplify it at all. That's totally fine. You don't have to be able to simplify it. We just have 7u minus 7 over 2a. Right? Over 2a, maybe we could, like, I don't know, use distributive and put it in, but that doesn't even look much simpler. So that's really your answer here. Okay, let's check out some more examples. Alright, so solve for b. We've got a lot going on here. Negative 6b over 5m plus the whole thing plus 12 equals 125x. Okay, a lot going on. But remember, we're just going to follow our good old friend SADMEP when we are applying inverses, right? When we're applying inverses, moving stuff across the equal sign, follow SADMEP, the inverse of PEMDAS, right? Because we're doing the opposite. Okay, let's see. So SADMEP says we're going to subtract before subtraction before multiplication and division here, right? Okay, so I better do my 12 first there, right? Okay, so let's do it. Negative 12, and what happens? These are going to cancel, and then we're left with what? We're left with negative 6b over 5m equals 125x minus 12, right? Okay, good. All right, then we've got what's happening to be all this stuff, right? Stuff's being multiplied, stuff's being divided, and these things you can do in whatever order you kind of feel like. But to me, I want to get rid of fractions as early as possible. So I've got some stuff, the over 5m. I want to try to get rid of that. So the inverse of division is multiplication. So let's do it. Multiplication, multiply by 5m. And remember, like the last one, we can take this whole quantity and do it all at once, or you can do one at a time. You'll see it'll cancel the same way. All right, if we showed all of our fraction work, our under the hood stuff, right? Okay, and we'll do the whole side. This is where you're going to make a mistake. Well, this is where I make the mistake. Okay, 5m times the whole other side. Okay, and what happens? We got canceling happening. So we've got negative 6b equals 125x, keep that parentheses, minus 12 times 5m. Well, look what we can do with that 5m. Let's do that now while we're thinking about it. We can distribute it in to kind of simplify this. Maybe it gets simpler, maybe it looks more complicated, but it's nice to move that in while we're doing it. So 125 times 5, what is that going to be? That's 5, 10, 12, right? 5, 6. Is that right? You guys check me on that one. I don't know because I did it in my head. So this is an x, because the 5 can multiply with this. These 5 can multiply here. But then, how about my x and my m? We can't actually do that show that any simpler, right? So we'll just leave it, x and m that way. Okay, and then we have 12 times 5, and 12 and the 5m, right? So that's 5 and times the m. So how much is that? We've got, what, 60? And negative, right? Negative times a positive is still negative. 60 m is still there because that's being multiplied as well. All right, good. We fixed that side up. We've got negative 6b. Hey, this is starting to look familiar. I know how to solve this thing for b. If I forget the other right side, I can look at the left side by itself. Just divide. When I have multiplication here, apply the inverse operation, which is division. So that's negative 6. Divide the, and now again, here, same kind of thing when we did multiplication. The division also applies to the whole thing. The whole thing. Okay, now is this going to look really nice? Probably not on the right side, but the left side looks great because we're left with b. And what does this thing equal? Oh my gosh. I'm not even going to try to do this one in my head, but that's 625 over negative 6 times xm, right? That kind of thing. You don't have to put the times in. And then we've got 60. I can simplify that one in my head. Minus 10, right? M, right? Because this 6 distributes. It's multiplication and division are the same thing, but it's just by the reciprocal, right? So there's also distribution happening here. When I divide the whole side, I'm also distributing my division as well as multiplication. And there's our final. And whoo, that guy's a beast. But we got it. And B is alone. I hope that was helpful.